Good evening, everyone. Welcome to BYJU'S exam prep. So today we are going to have a session on counting of figures. Okay. So if we talk about the abstract reasoning section, I told you last time that. Okay. So let's start with a very basic rule of counting figures. Okay. So how many triangles are there? Can you count the number of triangles and tell that how many triangles are there in the first figure, second figure, third figure? Can someone tell me how many triangles are there in this figure? So if we see this, there is one triangle, this smaller triangle, and then there is the larger triangle. Okay, so there are two triangles in this figure. Okay, now if we see this figure, how many triangles are there in this figure? The second one. Let's count and tell the number of triangles in this. So first one was simple, two triangles. This is triangle one, and the larger triangle is the second. How many triangles in this figure? Okay, Pranali says four triangles. Anyone saying more than four? 10 triangles. Talking about the second figure or the third figure? Okay, so let us count the number of triangles. One triangle is that smallest triangle. Then we have second triangle. Then we have the third triangle. And then we had the fourth triangle. Right? So there are four triangles. How do we find the number of triangles? So let us understand a generalized thing. In this, there was one line. In this, there were one, two, and three lines. So if you cut a triangle horizontally, parallel lines, so if the number of lines is n, there will be n plus 1 triangles. Okay. Now let's count the number of lines: 1, 2, 3, 4, 5, 6. So 6 lines, that means there will be 7 triangles. Okay. So that is the one of the basic rules, right? One basic rule is if you cut horizontal parallel lines, so the number of triangles is n plus 1. Okay. Now let us find the number of triangles in these figures. How many triangles are in this figure? At times you see the names of triangles given that they mark the points A, B, C, D, E, F, G, and then that say that these are the triangles. So if you see, this is one triangle on the left hand side, one triangle on the right hand side, and one combined triangle. Okay, so there are three triangles. Okay, can you tell me how many triangles are there in the second figure? How many triangles are there in the second figure? Okay, so Mohit Rao has told about all these figures. So second figure, if you see, there is one triangle like this. There is second triangle with this as the base. The third triangle with this as the base. Okay. Now if we see this triangle, that is the fourth triangle that we have. Then if you look at this triangle, this is triangle number 5. And then there is the outermost triangle, okay, which makes it triangle number 6. So there are 6 triangles in this figure. So it was easy to find, right? Now if we have 4, so we will count 1, 2, 3, 4, and then they will say that these two will make it 5, these two will make it 6, these two will make it 7, then these three will make it 8, these three will make it 9, and the total overall will make the 10th triangle. We can still count, right? But what if the number of the number of lines keep on increasing? We should have some generalized formula for that, isn't it? See, in permutation combination, what happens? If the values are small, you are able to count. But if the values are large, then you need the formula for permutations and combinations. Likewise, here also, if the number is small, we can easily count. But if the number keeps on increasing, then we have the formula. So basically, it is 1 plus 2. Here it is 1 plus 2 plus 3. Here it is 1 plus 2 plus 3 plus 4. So the sum of first n natural numbers is n plus 1 by 2, where n is the number of partitions. Okay. Now if you see 1, 2, 3, 4, 5, 6, there are 6 partitions. So number of triangles will be 6 into 7 by 2, that is 21 triangles. So you are not supposed to count them. Now in this case we could still count, but as the number grows you need to use this concepts. So in this case the number of triangles is n into n plus 1 by 2, where n is the number of partitions. So 1, 2, 3, 4, 5, 6 partitions. Okay, so that is the rule of when you have vertical partition. Okay, then mixing both these. If you have this also, now if you have to find the number of triangles in this scenario, what will be the number of triangles? So we can count in this, right? We can say that, okay, this is the first triangle, this is the second triangle, this is the third triangle. And then we see that 4 in the bottom, 5, that is this larger triangle are 4 and 5. And then the grand triangle, the biggest triangle, that makes it 6. Give 6 here. Now the problem will become complicated as we have a larger figure, right? It was a small figure, so we could easily count, right? But if the problem becomes larger, it will be difficult to count, right? So I just told you that if you draw the horizontal line, it separates into two triangles, right? When we talked about if there is one line, then you will have two triangles. If we talk about the vertical lines, we have one vertical line, and we just discussed that there will be three triangles. So there are total of 6. You just multiply by the number. Okay. Now if you have to find this, there is one horizontal line. So that means horizontally it will cut into two triangles. And if we talk about the vertical lines, there are three vertical lines, three partitions, 1, 2, 3. So that makes it 6 triangles, right? N into n plus 1 by 2. So if we multiply this, we get a total of 12 triangles. We can still count 12 triangles in this, but if you know how to find why to count, just multiply and get the values. Now suppose if you are given a bigger picture, count the number of triangles in this, count the number of triangles in this. Now that thing will be helpful in this. So tell me the number of triangles in these two figures. How many triangles are in this figure and this figure? Again, as I said, you are not supposed to count, right? We shall use the formula, right? So there are two lines, so it will break into three triangles. And there are three partitions, 1, 2, 3 partitions, that means 6. So 3 into 6, 18 triangles. Okay. Second one, there are 1, 2, 4 lines, so 5 partitions, 5, and there are 1, 2, 3, 4. 4 means 10 triangles. So 5 into 10, we have a total of 50 triangles. So we are not supposed to count, we can just tell the numbers by. Okay. So that was about drawing horizontal and vertical lines. Now let us see some more varieties. How do we find triangles in different kind of shapes? Like this is another shape wherein there is a triangle inside a triangle. How many triangles are there in these figures? Sometimes you will have triangle inside a triangle. So once you know these concepts, you can apply these collectively to find the number of triangles in that given figure. What is the number of triangles in figure A? Okay, first you will say 1, 2, 3, 4, and the larger outer triangle, 5 triangles. What about the second figure? Nine and 13. So if you see this part, the part which is inside this is the inversion of this. ये ऐसे था, इसको अगर उल्टा कर दोगे तो ये ऐसे बन जाएगा. So it is the same shape in the reverse format. So 5 triangles तो इसी part में हो गए, right? Just this part has 5 triangles. Then this is 6, 7, 8, and the larger triangle. So there are total of 9 triangles. Okay. Now if we see the third figure, so this is 5 triangles, right? Then you have 6, 7, 8, and this is 9 triangles. So basically this thing inverted, right? So what we had here, this inverted goes into this, right? So 9 triangles, and then we have this is this 6, 7, 8, then this larger one was 9, then 10, 11, 12, and the largest triangle, that is 13. Okay, so basically the like it is the number of layers into 4 plus 1, right? So here you have one inside layer, so we have 4n plus 1, so there is one layer inside. In this there is 1 and 2 layers inside, right? 4 into 2 plus 1. Here we have 1, 2, and 3 layers inside, right? So 4 into 3 plus 1. Okay, so if you have triangle inside triangle, you can find the number of triangles in that. Okay, all right. Now if you have combination of images, right, how do we find the number of triangles? This is a combination of, like, these two formats have combined number of triangles. Remember the rules that we just saw. Okay, so if we see this triangle, there is one triangle, large triangle. Now if we see this triangle, this part, how many triangles does it have? It has two partitions, right? So 3 triangles, 1, 2, 1, 2 and the 3 combined. This line will also make 3 triangles here. This will also make 3 triangles here, right? So 1, 3, 3, 3, 10 triangles, and then the larger triangle. So total of 11 triangles. Okay. So we just combine all the learnings that we saw, right? So 3 triangles from this, 3, 3, 3, 1 in the center and the outer triangle. Now in this case, we know that this part is 1. Okay, so this, we know this shape is 5 triangles. So this shape itself has 5 triangles, including this triangle itself. Now we have 1, 2, 3 triangles here, right? Because you have 2 partitions, so 3 triangles, 3 here, 3 here. So we have 14 plus the outermost triangle, that is 15 triangles. Okay, so 11 and 15 triangles, these figures. Right, so we are using the combinations of things. Now let us find the number of triangles in this case. Can we tell the number of triangles in this figure? Is it easy to count, or how is it, right? Is it, can we easily count this, or like will it take a lot of time? How many triangles are in this figure? 15. Okay, so let us count the number of triangles. Okay, let us first count, then I'll give you the method also, right? You should not be counting in that scenario. So one triangle is the top triangle. Then we have 2, 3, 4, right? 5, 6, 7, 8, 9, right? So that side where the length is 1, we have 9 triangles. Now let us count the number of triangles that have length 2. So one triangle is this, 1, 2, 3, 4 combined, then 2, 5, 6, 7 combined, then 4, 7, 8, 9 combined. 3 more triangles. Okay. Do we have any other triangle with length, side length 2? No. And then we have the outermost triangle. Okay, so we get 1 to get the total of 13 triangles. We were able to count 13 triangles. Okay. Suppose we have this triangle, right? Count the number of triangles in this. How many triangles are in this figure? Now this becomes a challenging one. Previous, okay, easy to count. Now if the number increases, it will be difficult to count also. So how many triangles are in this? How much? What is the number that you are getting? 23. Anyone getting more than 23? 24, 22. Yogita is getting 27. Now it becomes difficult, right? As the number increases, it becomes difficult to count. That is why I told you that those concepts, right, in the previous ones also. Now let us see that how to count. Then we will see that the method also, and to remember the values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 14, 15, 16, right? 16 triangles of side 1. So first of all, let us find side 1 triangles. Side 1 means like length is 1, right? Let's say this is 1 centimeter. So 1 centimeter wale 16 ho gaye. Okay. We'll count of side length 2, okay, 3 and 4. 4 length wala to ek hi hoga, the outermost one. Okay. Now let us count the triangles that have side length 2. So one triangle is 1, 2, 3, 4. One triangle, two triangle, three triangles, right? 4, 5, 6. 6 triangles. And then you have, see this inverted triangle also. So there are total of such 7 such triangles. There are total of 7 such triangles. Okay. 1, 2, 3, 4. Right. Then we have 2, 5, 6, 7, 4, 7, 8, 9, and 3 on this space, and then 1 inverted. So 7. Okay. Let us count the triangle with side 3. Okay. Now if we see side 3, one triangle is this large triangle. Then we have this triangle. And then we have this triangle. Okay. So there are 3 such triangles, and side length 4, there is one grand triangle. So we have 27 triangles. Someone said 27. Yogita, your answer is right. 27 triangles. Okay. Now if I give even a bigger figure, it will be even more difficult to count the number of triangles. Okay. So what these kind of shapes wherein you have this symmetry, this kind of symmetry. Okay, I'll give you the number of triangles for different things. Right? So if you have base 1, then the number of triangles is 1. For 2, it is 5, 3, 13, 4, 27. If they give 5, 48, they won't give beyond this. Right? They might just give you 5 or maximum or not beyond that. So there's a formula for it. Okay, if you want to remember this formula, I mean you can remember these values because they won't give beyond this, right? So there is formula n plus 2, 2n plus 1 upon 8 if it is even. Okay, and then if it is odd, if this is odd number. Okay. So let us just see for 6. We can verify for 6. So for 6 it will be 6 into 8 into 13 upon 8 is 78. If it is 5, so 5 into 7 into 11 minus 1 upon 8. 35 into 11, 385, 384 upon 8. We will get 48. So that is the formula. If you want to remember the formula, this is the formula, or just remember the table. They won't ask beyond 5 or 6. Worst possible scenario, they will generally ask this, not beyond this, because they also know that one cannot count this, right? So basically, if you are given different kind of things, you just need to combine the number of triangles in all those scenarios and just add those. Okay. Now if you are given a diagonal in a rectangle, how to find the number of triangles in that? How many triangles are in this figure, this figure, this figure? There's a very easy way to find the number. Can you tell the number of triangles in this figure, the first figure? 8. We will say 1, 2, 3, 4, then 5, 6, 7, and 8. Then the answer is 8. What about second, third? there is a very simple concept in this. Whenever you have both diagonals, like you have both diagonals, right? So count the number of smaller triangles. 1, 2, 3, 4, 5, 6. 6 triangles into 2, that will be 12 triangles. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8 into 2, 16 triangles. The condition is both diagonals of the square or rectangle should be. Right. So here also we have both the diagonals. Here also we have both the diagonals. Okay. That is the number of triangles in this. Right. Okay, so let us find the number of triangles in these figures. This figure and this figure. How many triangles are there? So how do we find the number of triangles in this scenario is or any other scenario wherein there are multiple figures involved? First of all, we count the number of triangles in individual elements, right? So we know that it has 8 triangles. This also has 8 triangles. Okay. Then first we find the individual number. Thus we find the common triangles, which are not existing in them individually, but only when we combine them. So if you see this, there is one triangle like this, which is not present individually, but when you combine these two, we get this triangle. Similarly, there is a triangle on the bottom as well, which was not present individually, but when we combine, we get this triangle. So 8 plus 2 plus 8 plus 8 plus 2, that is 18 triangles. Now, what will be the number of triangles in this scenario? How many triangles are there in the second scenario? So if we see like 8, right? There are 5 such things. So 8 into 5, 40 plus. Let us count the number of common triangles. Now this is between these two. This is between these two. 3, 4, 4 from base, bottom as the base, and 4 from top as the base. So 8. Total number of triangles is 48. So 18 and 48. Right. So whenever you have combination of figures, right, it could be any figure. It could be like this square tape, or it could be like this shape on top of this, right, and something like this. So see, you have to see that how many common triangles are also present in that. Okay. Okay. So I hope you are enjoying this session. So please do like the session. Now let us talk about the next thing, which is counting of squares. Okay. What is the number of squares in this figure? Maybe for small figure you can count, but for larger figure it becomes a challenging thing. How many squares are in this figure than the second figure? So first figure, I mean, we can manually count, right? But we will need to know the method to count in a larger figure. Okay. So first figure we can manually count 1, 2, 3, 4, 5, 6, 7, 8, 16 small squares, right? Side one, like as I said that side one, there are 16. If I talk about side two, then you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 squares of side length 2. If we talk about side length 3, okay. So side length 3, there are 1. This is 1 square. Then we have the second square like this. Then we have the third square like this. And we have one more square like this, 4. And if I talk about side length 4, the number of square is 1, the outermost square. Okay. So if we add this, we get 25 plus 5, 30 squares. Okay. So what do we see the pattern? We see 1 square plus 2 square plus 3 square plus 4 square. Okay. Sum of first squares of first and natural numbers is given by n plus 1 into 2n plus 1 upon 6. So n is 4. So 4 into 5 into 9 by 5 into 6, 30 squares. Now, if I have to find for this, I will not be counting manually. I know that this is the number n plus 1, 2n plus 1 upon 6. So 1, 2, 3, 4, 5, 6, 7. Right? So there are 7 smaller squares. So 7 into 8 into 2n plus 1, that is 15 upon 7 into 20, 140 squares. So no need to count manually. Know this here. I mean, know this value n into n plus 1, 2n plus 1 by 6. Okay, so that was perfect squares, right? Where the number of rows and columns was same. Now, what if the rows and columns are not same? How do we find the number of squares in this case? In the first figure, second figure, how many squares are there? Now here the number of rows and columns, we have 1, 2, 3, 4, 5 columns, but there are 1, 2, 3 and 4 rows only. What is the number of squares in this? So how to do this is, right, first multiply 5 by 4. 5 by 4 is 20. Then we have 4 into 3, that is 12. Then you have 3 into 2, that is 6. And 2 into 1, that is 40 squares. The answer will be 40. Suppose we have to find in this case. So it is 5 into 8, that is 40. Right? 4 into this is 4 into 7, that is 28. Then it will be 3 into 6, 18. 2 into 5, 10. And 1 into 4, 4. Okay. So it is 5 into 8, 4 into 7, 3 into 6, 2 into 5, and 1 into. So just add these 68, 86, and that is 100. So there are a total of 100 squares. Okay, so that's how we get the number of squares in such figures wherein the number of rows and columns are not equal. Okay, if the rows and columns are equal, we use n plus 1 to n plus 1 by 6. Okay, all right. So let us look at the case of number of rectangles. Right? How many rectangles are in the given figure? How many rectangles are there in these figures? Okay, so let us see the number of how do we find the number of rectangles in this case is right. So whatever is the the number of rows 1, 2, 4, 5, and the number of columns is 4, right? So it is r into r plus 1 by 2 into c plus 1 by rows. So there are 5 rows. So 5 into 6 by 2 into 4 into 5 by 2. So there is 150. Okay, so this is the number r into r plus 1 by 2 and c into c plus 1 by 2. Okay, in this case it will be 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8. So 5 into so 10 into 54, 540. And in this scenario, 1, 3, 4, 5, 6, 7, 1, 2, 4, 5, 6, 7. It is 7, so you can say that and just into this, so square 28 square, that is 784. 777. So that is the number of rectangles. So counting rectangles is just simple, right? So r into r plus 1 by 2 into c plus 1 by 2. So this thing you must have learned in permutations and combinations also, right? Okay, how many rectangles are there in a given image? Okay, so that like different forms in which triangles can be asked to count. Okay, and like if you have to count squares and rectangles also, for we saw the formula, right? If it is a perfect square, how to count the number of squares. If it is not a perfect square, counting the number of squares, counting the number of rectangles. So I hope you liked this video, you found this video useful, so please do like it. Okay, and in the coming sessions we'll discuss more such things, right? Last time we had mirror and water image, today we did counting of figures. We will solve different problems related to different topics tested in abstract reasoning in this video series. And you can also join us on our social media platforms like our Telegram channel and get your queries resolved by our experts. So thanks for watching this video. Have a great night. Goodbye.